In Algebra 2, as we work with trigonometry, we've introduced the idea of identities, and in this lesson we'll go ahead and review a couple of those identities we've already learned and introduce a couple new ones. So our objective is to be able to know some of the trig identities. So first of all, let's do a little bit of review. We're going to look at visuals of how some of these work with circles on a coordinate plane. So if we look at this coordinate system here, if we draw a radius here out to the circle, this is our radius, then if we drop this down here, this is our x value and this is our y value here on the circle. So this would be an x and a y. Now notice that if we have those values here, if this is our theta here in the triangle that we have, because it's a right triangle, we can use our trig identities to say that sine of theta is equal to the opposite over the hypotenuse, so y over r. Cosine of theta is equal to the adjacent over the hypotenuse, which is x over r. And tangent of theta is equal to the opposite over the adjacent, which is y over x. So these are how we use the coordinate system to find sine, cosine, and tangent. And of course we could use their reciprocals as well, but we're going to focus on sine, cosine, and tangent here. Now, if we look at a unit circle where that radius is equal to 1, so if this radius is equal to 1, then notice that when I drop this down here, this perpendicular, okay, this value here, because notice that r is equal to 1, sine is just equal to the y value. So this value here is the sine, okay, sine, and then cosine would be x over 1, so this would be the cosine here. So this ordered pair here, instead of being just xy, it would be cosine, comma sine for that. Now, that's helpful to visualize, to see on a unit circle that sine and cosine become the x and y as part of that. And we'll come back to this in a little bit to add in tangent as well. So let's go now to looking at our quadrant values. And up here then, just a reminder then, on the unit circle then, this is, I'm going to put here unit circle only because our r is equal to 1. Sine of theta is equal to y. Cosine of theta is equal to x. And tangent of theta is still equal to y over x. Okay? So now we have that on the unit circle. Make sure that's the only time you use that. All right, let's look at our quadrants now and talk about our values. This is where we're going to look at positive or negative. And because in this quadrant, x and y are positive, so in these two quadrants, x is positive. In these two quadrants, y is positive. And then we'd have negative y's down here, and we'd have negative x's over here. Because of that, we developed the fact that the different trig functions, because of these x, y's, and r's, r always being positive, you're going to have that sine theta here is going to be positive, cosine theta will be positive, and tangent theta will be positive. And they're reciprocal, so all trig functions are positive in this quadrant. In quadrant 2, on the other hand, sine is still positive, but cosine becomes negative because x becomes negative, and tangent also becomes negative because it has one negative and one positive. When we go down to the third quadrant, sine becomes negative because the y value is negative. Cosine is still negative because we're over on this side of the y-axis where x's are negative, but tangent will be a negative over a negative, so that will make it mean it's going to be a positive. And then lastly, in quadrant 4, we're going to have over here that sine is negative because y is negative. Cosine has become positive because the x is positive on this side of the y-axis. And then lastly, tangent is negative because you have one positive, one negative. So one way to remember this process of which ones are positive and negative, we can use the phrase, all students take calculus. That's just a reminder, if you use this phrase, all of them are positive in quadrant 1. Quadrant 2, we've got sine is positive. Tangent's positive in quadrant 3. And then lastly for quadrant 4, cosine is positive. Okay, so those are helpful to find out if you've got positive or negative values for your trig functions. All right, let's keep going on this. Now these are review of identities that we've already talked about. These identities have to do with our x's and y's and things like reciprocals and why we call it cosine in relation to sine. So our reciprocal identities is that if you want to find secant theta, you take 1 over cosine theta. It's the reciprocal. If you want to find cosecant theta, you take 1 over sine of theta. And if you want to find cotangent of theta, that's 1 over tangent. So this is just a reminder of the relationship between those two as reciprocals, and that will help us. Now the co in co-function refers to complement. What that means is that when we were doing these different trig functions, the sine and the cosine are related, that their angles, if they're equal, are going to be complementary. What that looks like is if you want to find cosine of theta, you're going to take sine of, if you've got an angle, and subtract it from 90 degrees. Because if you add two angles, this plus this, because that's a negative, you get 90 degrees. So subtract it from 90 and you get that. And if you want to find, for instance, if you want to find cosecant of theta, the cosecant, you'll do secant and subtract it from 90 if we're dealing with degrees to get the complementary angle. And then lastly, if you want to do cotangent, you do the tangent of the complementary angle. Now it's interesting to note just the relationship. Cotangent and tangent are not only reciprocal, but they're co-functions. So they've got kind of both of those going for them in their relationship together. All right, now what we want to do is we want to introduce two new identities. So these identities are going to be related to what we've talked about with our x, y's, and r's. So if you look at here, if I look at my, again, my units, my circle with x and y here, okay, and we have this problem, okay, remember we had these values here, x and y. If you look at this, the tangent identity comes from the fact that if you remember, you've got sine, up above we said sine theta is equal to y over r, and we said cosine of theta is equal to x over r. Now, what if we put sine over cosine? Sine of theta over cosine of theta, that equals y over r over x over r. And if you use the algebra on that, y over r times you take the reciprocal of the denominator fraction and multiply it, r over x. These r's cancel and you end up with y over x. Well, what is y over x? Y over x is the tangent of theta. So what we have here is a new identity, that the tangent of theta in a triangle like this, tangent is equal to sine theta over cosine theta. All right, so that's a new identity, that if you know the sine and cosine, you can find tangent by setting them up as a fraction of sine over cosine. Now I'm going to go back up to our diagram up here, just to add on to this. We have something else we can visualize here, that if we draw the tangent here, if you draw the tangent and extend this out to that point, you have another right triangle, and notice that these are similar triangles if you remember back to your geometry. So sine over cosine is the same as, this is the tangent visually, this height from here to here. So once we've drawn this, we've got now that from here to here is the tangent, and you've got similar triangles. And so this side here over 1, which is the radius of the unit circle, is equal to sine over cosine, because those are similar triangles. So visually in the unit circle, sine is the y value, cosine's the x, and then if you draw a tangent out here and extend out, that length is the length of tangent. All right, let's go back now and let's do our Pythagorean identity. On this one, again, we're going to use, go back to using our x, y's, and r's. So Pythagorean identity, if we do use our triangle again here, where we've got this is equal to r, this is equal to x, and this is equal to y. Notice that on this, we can use the Pythagorean theorem on it. Let's go ahead and use that with sines and cosines. Notice that if we have sine squared of theta plus cosine squared of theta, sine squared theta is going to be y over r on that triangle, plus x over r, and we're going to square those. If we square these, we get y squared over r squared plus x squared over r squared. Now we've got a common denominator, so we can say y squared plus x squared over r squared. Now you might say, what is the difference that make? Well, look back at this triangle. On this triangle, Pythagorean theorem tells us that x squared plus y squared is equal to r squared. So I can substitute r squared for this. R squared over r squared is equal to 1. So notice when I did sine squared theta plus cosine squared theta, I ended up with 1 because of using the Pythagorean theorem. That's why this is called the Pythagorean identity. So an identity is if you have sine squared of any angle plus cosine squared of any angle, that's going to equal 1. So what we've done is we've looked back and reviewed over some of the visuals we have for coordinate geometry and trigonometry. We've also reviewed over some of the previous identities we have used, and now we've introduced 2 new identities we can use in trigonometry.